Oh, you filthy swines! Get in here, sit down, and behave yourselves. I'm going to read some stuff. You might like it, I don't know. Maybe you won't, I don't know, but I will. I'm a huge science fiction nerd, and I enjoy finding instances of anomalies and discoveries and stuff, and wondering what actually could be the most extreme outcome of that. And I was watching a video the other day of one of my favorite YouTubers, a chap called Anton Petrov. He's pretty cool. And there's been this interesting discovery by amateur astronomers of a nebula in front of Andromeda. And Andromeda is on a collision course with the Milky Way. So this, I imagine this nebula is in front of it. I don't know if that means it's traveling faster than Andromeda. I'm not exactly sure what the relationship here is, but from a website called rmg.co.uk, written by somebody, I'm not exactly sure who, I'd credit you if I could, Andromeda Unexpected, how 3 amateur astronomers and astrophotographers changed our view of the universe. With hundreds of observatories worldwide surveilling the sky and extremely high-tech cameras zipping around the solar system, you might assume there's nothing left in space for an amateur astronomer to discover. Well, the space is actually ridiculously big. So until we get our AI act together and scan the entire sky and have a bunch of AIs trawl it all, I'm sure there's a lot of discoveries out there that you could just pick out of the mess. Yet in 2022, 3 amateur astronomers and astrophotographers made a remarkable find in one of the most observed and photographed areas of the night sky. Marcel Dreschler, Xavier Strockner, and Jan Sainty discovered and photographed a never-before-seen oxygen arc next to our nearest spiral galaxy, the Andromeda Galaxy. This here is a bloody humongous blue sky hanging in the void between Andromeda and the Milky Way. Now, I don't know how dense this oxygen is. What kind of density of atoms would you need to occlude the stars behind you? What blew my mind basically is how gigantic this is, and the fact that it's basically a blue sky hanging in space. And why that blows me away is there are a number of novels about zero-G environments where people live, a number of science fiction novels. For instance, Larry Niven's Integral Trees and Stephen Baxter's Raft, and a novel called Virgo. It's a very popular theme that recurs about what would the experience be like if you lived in some kind of free floating atmosphere. Anyway, there it is. The hours of hard work put in by these passionate amateurs earned them the top prize in Astronomy Photographer of the Year 2023, the world's biggest space photography competition. Competition judge Laszlo Francis said of their image, "The astrophoto is as spectacular as it is valuable. It not only presents Andromeda in a new way, but also raises the quality of astrophotography to a new level." What did the team discover? The Andromeda Galaxy, known as M31, also known as Andromeda, why don't we just call it by its name, its Christian name, is the nearest large galaxy to us at around 2.5 million light years away. The earliest known photograph of Andromeda was taken over 130 years ago in 1888 by Isaac Roberts. And since then, it's been a hugely popular target of astrophotography. However, in 2022, the 3 astronomers and astrophotographers discovered a huge plasma arc in its vicinity, recognizable as the slightly curved blue cloud to the left of the spiral galaxy in Andromeda. Unexpected. What? Unexpected? Firstly, what is plasma? Plasmas have some similarities to gases, consisting of freely moving atoms which, through high temperature or radiation, have become split from some or all of the electrons that make them up. The result is a soup of electrons and partially ionized nuclei, which gives them some weird properties. 99% of the visible universe is made of plasma. We can see it in the form of stars, nebula, solar wind, and comet trails, the aurora, and more. What you see is the gigantic blue arc of ionized oxygen gas that has never been seen before. Amateur astronomer and astrophotographer Marcel explains. The arc is an emission nebula, which is a cloud of ionized gas that emits its own light at an optical wavelength. Stretching 1.5 degrees across the sky, it appears to be almost half the size of Andromeda Galaxy. So it's a region of ionized oxygen the size of a galaxy. As a result, it could be the largest and closest such structure to us in the universe. The team wrote in their application to Astronomy Photographer of the Year 2023. The arc has now been named the Strata Drechsler Sainty Object, SD-SO1. Scientists worldwide are collaborating to investigate the arc further, including its potential relationship to the neighboring galaxy. Why hasn't it been seen before? Over 100 years, nobody has seen the arc because it's so faint and it's only visible in oxygen-3. Marcel explains. When gases like hydrogen, sulfur, and oxygen are superheated, they glow in various colors, with oxygen giving off a blue color. Telescope narrowband filters allow astronomers to look at the light from certain gases, with the most common filters being hydrogen alpha, hydrogen beta, sulfur 2, and oxygen 3. As 3/4 of the gas of the universe is hydrogen, the astrophotographers tend to take photos using hydrogen alpha filter in order to see this type of light. Oxygen, by contrast, makes up just 1% of gas in the universe and is extremely faint, making it difficult to see. Isn't it extremely bizarre that such a large expanse of oxygen is floating in space? Is that weird? It seems weird. Photographs taken with an oxygen-3 filter are also subject to distortions from factors such as light pollution, meaning fewer astrophotographers choose to use it. Oh yeah, we're trying to photograph oxygen through a whole bunch of oxygen. It's kind of difficult, maybe. I don't know, I guess. However, for those willing to put in the long exposure times required to take photographs in oxygen-3, many discoveries await. The arc is not very easy to capture. You have to be an ambitious astrophotographer to catch this arc, Marcel says. Bright oxygen clouds have already been discovered in other nebulae, such as the Veil Nebula, where oxygen gas is heated, ionized, and glows blue. Looks pretty awesome. Some of it's red, though. I've noticed that just now with my eyes. So how did the team find it? Marcel explains it was an absolute accident. No one expected to see it, and that's why it's called Andromeda Unexpected. Because we wanted to take a beautiful image of the Andromeda galaxy. When we looked at the first data, and we spotted this hazy smudge to the edge of the image. The astrophotographers originally thought the smudge could be an artifact, an anomaly or distortion which shows up on an image due to interference from things like light pollution, satellite trails, and scattered light. After much discussions, however, we came to the conclusion no, it's not an artifact, it's real, it's a new discovery. Marcel says, why haven't any of the extremely sophisticated cameras in space spotted this? Essentially, while space telescopes take extremely valuable photographs, they have limitations in their scope. We amateur astronomers can capture what Hubble and the James Webb Space Telescope can't because they only capture a teeny tiny fraction of the sky. Marcel explains. With our small and not so expensive telescopes, we are able to capture a wide field image of the night sky. We are faster than Hubble, we have a wider field than Hubble, and we can do more exposure times than Hubble. When you have a very tiny bright nebula, you call Hubble, but when you have a very faint object in the Milky Way, you call us amateur astronomers. Also, I would imagine over time, these amateur astronomers' telescopes are getting more and more powerful. And also, AI is got to be hugely impactful for astronomy, particularly for amateurs, for spotting anomalies and such in anything they can capture. He explains that thanks to increasingly sophisticated equipment available, amateurs can act as the eyes and ears of professional astronomers due to their passion, dedication, and time. How did they take the photo? Each member of the team brought their own specialisms to the table to create Andromeda Unexpected. These are they, by the looks of it. Marcel explains, Xavier is a very good researcher and analyst, and Jan is doing a great job of capturing the data. My part is the image editing. I'm taking the raw data and making a beautiful image out of that. According to amateur astrophotographer Jan, it's a sharing of knowledge which results in everyone learning new things. Firstly, Marcel and amateur astronomer Xavier discovered a potential planetary nebula, and they commissioned Jan to shoot the data. Jan wanted to experiment and shot Andromeda with a special filter, hoping to discover a planetary nebula. But what Marcel and Jan and Xavier discovered in the data exceeded their expectations. Jan took photos of Andromeda using a range of filters. Upon sending the data to Marcel and Xavier, they noticed something very faint that merited further investigation. As a result, over 22 nights, Jan diligently captured around 110 hours of data in various filters with a range of exposure times. Weather was an issue. Jan had to follow the weather from the north to the south of France, traveling each day to various locations that would allow a clear sky that night. Stacking Jan's images taken with various exposure times allowed the team to create a median image, toning out the noise from individual images. It also allowed them to filter out other blue light emitters that were showing up in the Oxygen 3 filter. Data from 5 other telescopes in France and the USA verified the presence of the oxygen arc. Jan's raw data was handed over to Marcel, who processed the image. For me, as the picture editor in the team, it's most important to combine the aesthetic of astrophotography with the scientific aspect and merge it together to make it a wow image. Jan reminisces, the first time we saw the image, we were blown away, as much by the arc as the detail in the galaxy. For Marcel, Xavier, and Jan, it was astrophotography that brought them together. Marcel says, our group first met on the internet, and since then we have worked together on projects remotely. The team became good friends during the process of discovering the arc and learnt a lot from each other, despite living far away from each other. We have very much the same vision, the same values. It's enriching to work with people like this. It was a privilege for me to work with them and get their expertise, says Jan, who is a relative newcomer to astronomy, having taken up astrophotography in 2020 during the pandemic lockdowns. The team working on the discovery has since expanded from the 3 photographers to include astrophysicists, astrophotographers, and scientists worldwide. This includes Robert Fessin, professor of physics and astronomy at Dartmouth College in the USA, was the scientific lead alongside Professor Stefan Keimswanger of the University of Innsbruck. Michael Scholl, professor of astrophysics at the University of Colorado, and Professor Quentin Parker of the University of Hong Kong also provided scientific support. Astrophotographers Bray Falls, Christophe Vergnes, Nicholas Martino, and Sean Walker, meanwhile, provided astrophotography support. For me, the most important message is to work together in different languages across borders with an international community, says Marcel. To combine these skills and these people around the globe made this image and this discovery possible. But what is the significance of the discovery for amateur astronomy? Well, I suppose it's quite good, really. Yes, it's a good thing. This discovery reiterates the value of amateurs in the field and astrophotography as both an art and a science. Amateur astronomers can say, we are the eyes of modern research, suggests Marcel. There are thousands of us. We have a lot of time. We have good equipment and we are spread around the globe. It is the sheer number and the passion of us amateurs that makes a difference. You could make a very large compound telescope by combining the sources of multiple telescopes into one image. I think that's a common feature of a lot of these large arrays. So yeah, if you have a bunch of amateur astronomers, I bet they can do some pretty impressive stuff if they work together. For those with the time and interest in astrophotography, Jan advises people to not wait. I would say to everyone interested in astrophotography not to hesitate to take it up. Try with whatever equipment you can. With a little bit of training and learning, it can be accessible to you. It opens up marvelous doors. Xavier adds, to be able to have our name on this object forever, that is a real legacy of the future. Marcel, Xavier, and Jan would like to thank all the people who worked on the discovery, blah, blah, blah. No one's going to fess up to writing this, though. It's most likely just a very large, diffuse, ionized cloud of oxygen, but wouldn't it be interesting if this were some kind of generation starship in a sense? Imagine some beings in Andromeda knew that we were going to collide with Andromeda and they wanted to send a party of people to the Milky Way to make sure that the collision wasn't a catastrophe. How would you do that? would you create a giant bubble of oxygen and send it across space? Probably not, but hang on a moment, maybe it's possible. Andromeda burped out a giant cloud of oxygen, and inside this cloud that's traveling faster than Andromeda are a bunch of aliens who are living out multiple generations as that cloud gets closer and closer to the Milky Way. And when they get here, who knows? Who knows? But those books that I mentioned earlier on, Integral Trees is great, and Raft by Stephen Baxter. They're a really interesting idea for a story world, because if we do become spacefaring and people do live in zero-G environments, I wonder what will be the largest zero-G atmosphere that we could create. Because at a certain point, would there not be some kind of gravitational attraction? Would this cloud not kind of clump together? I wonder how dense it is. Probably not that dense. I mean, Mars has 1% atmospheric pressure compared to Earth, but I bet it's even thinner than that. But you can dream if you wish. Thank you for joining me. But that is it for now. Make sure you hit the like button if you do indeed like me. Follow me if you like me long time, and come back in the future to see what I'm doing. And the only thing I have left to say is Pigwig out.
Oink, oinkity, snort, snuffle, snuffle, squee, oink, oink, wee, squeal, snort, snort, oinkity, squee. Oink, oink, oinkity, squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinkity, oink, snort, snort, squee, oink, 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 wee, 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 oh. Snort, snuffle, oink, squee, squeal, wee, snort, oinkity. Oinkity, oink, oink, snuffle, wee, squee, snort, oink, squeal. Oink, oink, oinkity, squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinkity, oink, snort, snort, squee, oink, 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 wee, 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 oh. Oink, oinkity, snort, snuffle, snuffle, squee, oinkity, oink, oink, snuffle, wee, squee, snort, oink, squeal. Oink, oink, oinkity, squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinkity, oink, snort, snort, squee, oink, 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 wee, 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 oh. Squeal, squeal. Snort, snuffle, oink, re, squeal, re, snort, oinky. Oinkity, oink, 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 snuffle, wee, squee, snort, oink, squeal. Oink, oink, oinkity, squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 wee, 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 oh. Squeal, squeal, snort, snuffle, oink.